Section 3.1, types of sets and set notation. So what categories can you use to organize your clothes? So you could organize them into tops. Those things include t-shirts, sweaters. I don't know what the difference between a sweatshirt and sweater is, actually. Oh, maybe sweaters are more fancy. Whatever. Socks, sports clothes, casual clothes, dress clothes, summer clothes, outerwear, footwear. So something to notice is that in sports clothes, you might also have tops. In casual clothes, you have tops. So sometimes the way you categorize, it's not easy to put distinct things in. So we're going to learn about sets and subsets. Here we have Jasmine. She's studying the provinces and territories of Canada. She has decided to categorize them using sets. And sets is a collection of distinguishable objects. For example, the set of whole numbers is 0, 1, 2, 3, 4, 5, etc. Okay, so how can Jasmine use sets to categorize the regions? List the elements. Elements are objects of the universal set of Canadian provinces and territories. So this is everything. We have Yukon, and I'm just going to use abbreviations. We have Northwest Territories, Nunavut, BC, Alberta, Saskatchewan, Manitoba, and normally we would just write this all between. And we use these big curly brackets to show everything in the set. Manitoba, Ontario, Quebec, New Brunswick, Nova Scotia, PEI, and I almost forgot Newfoundland, Labrador. Interesting information. Ms. Cantlon's been to everywhere except for the territories. There you go. Maybe you could say the same thing. One subset of C, if C is all of the provinces and territories, remember this is how we define C, is a set of Western provinces and territories. So let's write W. Which ones are Western? And I believe we say Western is everything from here on. That's what I'm going to call Western. Or should we say maybe Western? Whoops. Or should we say that Western is maybe everything from here on? Let's be easy on ourselves. Let's say that this is Western. Okay, so let's say Saskatchewan onwards. So we have Saskatchewan, we have Alberta, we have BC, we have Northwest Territories and Yukon. Okay, this Venn diagram to the right represents the universal set. So everything here is everything in Canada, all the provinces and the territories. The circle represents W, the Western. The complement of W is given as W tick or W prime. The complement is all the elements of a universal set that do not belong to the subset. So what's not in Western? Well, that's everything that we didn't write in the subset. So that would be, in our case, Manitoba. We could, what else isn't in there? Nunavut. We have Ontario. We have Quebec. We have Nova Scotia, New Brunswick, PEI, and let's not forget Newfoundland and Labrador. So that's the subset. Everything out here is the subset, not included in those Western provinces, okay? The other thing I want to say is a subset. Notice that all of these elements are in the bigger universal set, which is all of Canada. So this language is going to seem pretty foreign at first, but hopefully it will become what we're used to. Explain what it represents in the Venn diagram. It represents everything that isn't Western. Jasmine wrote the set of Eastern provinces, Newfoundland, PE, Nova Scotia, NB, QC, Ontario. Is that equal to that? Well, no, because we didn't include these guys in Western. So they are not the same. If we would have included those ones in Western, this would have been, I think would have worked. Okay? So that's interesting. Sometimes a complement can be equal to a subset. Let's look next. List T, the set of territories. Is T a subset of C? Is it a subset of W or a subset of W complement? Explain using your Venn diagram. So all the territories are Yukon, Northwest Territories, and Nunavut. I just want to read back here. So this was just called Western provinces and territories, so we didn't make a mistake. Okay, so now let's draw this. Well, Western included Yukon, Nunavut, or Yukon and Northwest Territories. So that means that this T is going to include a little bit of that, but include some stuff that is not in that. So T is a subset of C, but it is not a subset of W or a subset of W prime, because it's kind of like both. Okay? Next, it says, explain why you can represent the set of Canadian provinces south of Mexico by the empty set. An empty set is a set with no elements. Well, unfortunately, Canada doesn't have any provinces south of Mexico, so nothing's included it. So if we called this subset M, it would be the empty set. And the empty set is either shown by empty brackets with nothing in it, or we could say M is the empty set like that. Consider the sets C, W, W prime, and T. List a pair of disjoint sets. Is there more than one? Disjoint means two or more sets having no elements in common. For example, the set of even and odd. So are any of these, there's nothing in common? Well, W and W prime have to be disjoint. There's nothing in common. What about W and T? Did they have nothing in common? Let's look down. Oh, I'm going the wrong way. No, they had all of these elements in common. In fact, those elements were these two right here. Okay, so the disjoint means nothing in common. So just to summarize, we are going to read right here. The following is a summary of notation. So notation comes into play when we do sets. Okay, sets are defined using brackets. To define the universal set, we could go U equals those elements. To define a set A, we would say A is equal to that. All elements of A are also an element of U. So this is a subset, and that's what this little thing means, is a subset. A is a subset of U because 1 and 2 are included in 1, 2, 3. The set A is the complement of A. So everything that's not in A but is in U, that's how we write the complement. Okay, and to define a set that contains the number 4, well, we could say B is the empty set, or B is the empty set. That's how we say empty set. And this is B is a member of U. This one I don't really like. So B is a subset of U. Well, it is a subset of U that contains number 4, but it's empty. Okay, I'm fine with that. Okay, so this work is a lot of notation. So looking back to your key ideas would be really important here. We're going to do a little more. You can represent a set of elements. Okay, you can also use set notation in this way. So if we were trying to say all the numbers 1, 2, 3, 4, 5, we could say all x. This line means such that x is greater than 0 and x is less than 6. So look, everything here is greater than 0 and less than 6. And x is a member of the integers because we're only using integers. We could have also written x as a member of the whole number. That would have worked as well. You can show how sets and subsets are related by using Venn diagrams. That's this thing right here. They do not usually show the relative size, so don't worry about drawing your circles. Okay, well, this is a smaller set, so it could be smaller. It doesn't matter. It just shows relationships. Sometimes it's an easy way to see. You can often separate a universal set into subsets in more than one correct way. Sets are equal if they contain exactly the same elements, even if the elements are listed in different orders. You may not be able to count all the elements in a very large or an infinite set. So for instance, if I said A was a set of all integers, I would not be able to count all the integers. The sum of the number of elements in a set and its complement is equal to the number of elements in the universal set. So if I said A and the number in A's complement, so all the integers, or here, let's say my subset is, my universal set is 1, 2, 3. So there are how many elements there? There are 3 elements. Oops. There are 3 elements there. And then if I said A is the subset with 1, 2, and B is the subset of 3. Well, if I took the number, that should be a squirrely bracket, the number in A is 2, there's 2 elements, plus, well, B is the complement of A, because it's what's in the universal but not in A, so that's just 3. 2 plus 1 is equal to 3. So 2 elements, 1 element, 3 elements. When 2 sets are disjoint, the number in A or B is equal to the number of A plus the number of B. So that's if I have 2 different sets. If there's disjoint, nothing in common, the number in A or B is equal to the number in A plus the number in B.